Here, do you want to take it away?
Yeah, so hi everyone. So it's a pleasure to present. So we wanted to basically give you some update as to what we've been up to these days and what is the main objective of this working group. So first we'll talk about motivation, so who we are and what is the context, and then we'll get into the core of that. So the co-chairs are Amy Braverman. She's more of a statistician. She's been working a lot with NASA on satellite imagery and things related to statistics applied to Earth system science. Libby Barnes, she's a climate scientist at Colorado State. Mike Pritchard at UC Irvine, also climate scientist, and myself. And I should mention also in the background, I mean, we've been getting some great help from Tom Beukler. He's a postdoc actually at UC Irvine and doing a lot of amazing work, we believe, on this topic. So what CLIVAR is about is really trying to look at climate variability and how does climate vary across multiple timescales. And so what we want to do is we want to basically look at analyzing data. So there's these observational data sets that we have, and then we also want to actually model things. And so now it seems that we are actually kind of facing a roadblock. Sorry, I think maybe if you can go back. Sorry, Mike. Thanks. Yeah, so, and the main trouble is that we are getting a tremendous and huge amount of data, and it gets very complicated to actually even analyze very simple things. So if we take the example of CMIP6, we're exceeding multiple terabytes of data, and the question is, how can we actually utilize and harvest those data sets in the most efficient way? And that's where maybe the intersection with data science comes in, and that's been generating more and more interest in the community. Thanks. So there are new tools to address that. So one good example has been the use of machine learning, and especially deep learning, using, for instance, deep neural networks as ways to actually emulate high-dimensional data. So we've been seeing a lot of examples and applications across the industry and different branches of science. And there's also been a lot of new development in statistics. So sometimes we focus a lot on machine learning, but there's been some really interesting statistical development, like, for instance, the work on causality, like, and things along those lines. And so why are we seeing a breakthrough these days in data science? So it's really this combination between hardware on the one side, where we have a lot of new hardware that we can really use, like GPUs and TPUs that were not really usable as much before and that are highly parallelized. And then in the meantime, we also have new algorithms that are coming along. So especially convolutional neural networks or things that are taking advantage of like space-time correlations. And so we are really witnessing as well a data explosion. So this combination of those three things really leads to a convergence that is really generating a breakthrough in many fields. And we believe that could be kind of the same in Earth system science, as long as we can really use that potential. And right now it seems a little bit underexploited to some extent. So we'll go quickly into a couple of examples. So some of them will be related to how we can actually use those tools to analyze data, especially very large data sets, interpret them, or even extrapolate data that we had that's sparse in space and time. And also trying to be computationally efficient and trying to replace physical processes or biological processes that we have in models that we don't really understand to their full extent. And of course, there will be many unforeseen applications that we don't really know right now. And so the objective is really of this working group is trying to get understanding, trying to actually develop new tools and tools that are suitable to the type of things we are actually dealing with, and trying to have them actually adopted by the broader community, and also in the meantime, trying to train the next generation of Earth system scientists. And in the meantime, there are questions that are very important, especially one related to reproducibility and interpretability. So we want to make sure that whatever is being done, especially as part of this working group, can actually be reproduced. So we want to have like best practices that will be basically applied to the whole community, or at least embraced by the community. And of course, there's always this question of uncertainty quantification. So that's not always what we see in typical machine learning application. But that's something we are very interested in. So if we think about, say, predicting or projecting climate change, we definitely want to have some error bars in there. So those are things that are very important and dear to this community. And so the main objective is trying to have a dialogue and hopefully have some progress in terms of combining different pieces together and different fields, especially like earth system science, computer science, or like machine learning and AI, and statisticians. And sometimes the dialogue is not yet happening, so we hope that we could generate some of that. Okay, so what are some of the applications that we've kind of been seeing, and what are the opportunities we are seeing? So some examples are, for instance, the carbon cycle, and looking at, for instance, the terrestrial or oceanic carbon cycle, where we know that we are really facing a roadblock in terms of predicting the fate of the carbon cycle. And we know that we have very loose constraints, and we don't really understand many of the processes that are at play, especially biology in particular. There's been a couple of examples where we can actually upscale data, so we can actually get quite a bit of data now based on, say, eddy covariance of flux tower data that are point scale observation, and we can upscale them to actually start getting a sense as to what is the global carbon uptake from like terrestrial continents, and that starts bringing further constraints for the modeling. So that's being really kind of at the intermediate between process level understanding and at the same time increasing the constraint on modeling. Mike, if you want to take.
Oh, sure, yeah. And this is stuff close to my heart, and just being dazzled by these amazing simulations that are possible now that resolve order-kilometer scale processes. And there's a lot of complexity that's missing in the parameterizations we rely on to produce estimates of climate uncertainty that is captured in these global cloud resolving simulations, but that are difficult to mine. So my own entry into this area was being surprised that in super parameterized simulations, where you have 10,000 cloud resolving models living inside of a global climate model as a way to sort of get a shortcut to convective permitting resolution, it turns out the actual physical equations that are solved in that approach can be emulated surprisingly well by deep neural networks, which is really exciting and opens up a lot of doors. Daydreaming more about what justice we could actually do to physical equations in the future if they're just to be outsourced to neural networks in the end. It's really sets the stage for a lot of daydreaming. But these are just examples, and more what there is right now is potential that needs to be discussed and distilled. Potential, just big picture issues like, we're all accustomed to familiar tools like empirical orthogonal functions for understanding the complex space-time relationships in data. But there are other ways to do that with modern tools. Pierre mentioned causal discovery, formal causal hypothesis testing and graph theory. That branch of data science is really interesting. We're trying to untangle what's forced and what's not in the climate system and geographic relationships. And we're seeing examples beginning to emerge in our field of tasking neural networks to answer questions like, what year is it, based on information that's just like what the temperature is on the planet at different geographic locations. And asking neural networks to predict this sort of information and then interpreting how they made their prediction is a really interesting new tack on trying to discriminate reliable indicators of climate change or forced modes of variability from noise. So there are many creative applications of neural networks that are just beginning to be explored. And this is more examples from Libby Barnes' work. I think I'll just skip over that. But yeah, the point here is really that we're taking baby steps at this stage. There's lots of interesting emerging tools and many challenges that we need to discuss. Okay, so here's some of them. For the portion of the community that's trying to just do unsupervised learning to automatically detect features that we know we're interested in, that humans are imperfect at labeling, like atmospheric rivers or tropical cyclones, to do extreme analysis. There's issues that need discussing. The mature part of image recognition has dealt with images with sharp edges, like cats and dogs, and machinery works great for there. But in the climate system, we've got water vapor fields that are blurry and have no sharp edges around an object of interest. Meanwhile, it's one thing to outsource some of these physics or some of this diagnostic to a black box machine learning network, but at the end we need to understand how the predictions are made. And so there's a whole subfield of interpretable machine learning that's really moving quickly these days. In the modeling world where I live, outsourcing actual physical calculations to neural networks only makes sense if you can force them to respect physical laws and mass conservation that are mission critical for climate prediction. Conventional neural networks in industry don't have that requirement, and so there's discussions that need to happen there as well. So the goal of the working group is to share more of these examples that are blossoming and try to do some synthesis across a diverse group of Earth system scientists and statisticians to hopefully articulate some best practices, but definitely exchange some ideas. And meanwhile, we'd like to curate some of that information for the community. So we have a few vehicles to do that through webinars. There was some interest at the last summer's steering committee meeting about training. And we've noticed that there's lots of training opportunities proliferating already around the country, so we don't see our main impact being there, but we'd like to curate those sorts of opportunities on our radar, summer schools at NCAR and climate informatics workshops, etc. And as far as what's happening, well, the working group has formed. So I think last summer we announced that the emails have been sent out, and we were delighted that everybody we invited responded. So here's the list of everyone involved. And we have, we think, a nice balance between a lot of early career people and good gender balance, and also good balance between the statistical community. So there's intentionally, many members of this working group that work in the field of statistics. And we're already discovering, as we've just begun to meet and get to know each other the last 5 or 6 months, that we have very different druthers. And it's turning into a really interesting conversation. Unfortunately, it's one that got cut off sharply when the pandemic exploded. We're just beginning to think about our little mini clusters and what we'd like to actually do together this year. But meanwhile, the bi-monthly webinars have begun. And these are our main vehicle for working group discussions with the community. So this is the main method that we're going to try to curate people's experiences from. And again, the goal here is to come up with an online presence that we hope will be useful to the community. And then that's to inform working group discussions towards identifying some synthetic activities that ultimately we hope will result in some working group publications beginning in year 2 and year 3. So that's the big picture. And so an example of something that we're beginning to identify the subtopics that actually have a critical mass of interest across this working group. And there are ones like interpretability, also transfer learning, so priority areas where we're realizing collectively that we all have in our different worlds interest and need to learn more. So that's ongoing. I'd like to encourage you to join our webinar series if you like. So it's every second Monday. It's happening at noon Pacific, 3 p.m. Eastern time. If you can't make that time, they're recorded on the US CLIVAR YouTube channel. We had our inaugural meeting just a couple of weeks ago. A senior statistician from the University of California, Berkeley, who was challenging us to think from her view and experience in genomics and medicine, really taking a hard look at all the things we tend not to write in our papers about the many choices we face in this cycle of data science, where we actually make decisions when we collect the data, when we clean the data, when we clean the data, that we don't consider formally the way statisticians might in medicine, in terms of this overall drive to having reproducible and actually data science that has some quantifiable uncertainty. So that's already been a healthy challenge that sparked some interesting discussion across the group. Next webinar is coming up on Monday, and we'll be having Polong Ma from Duke University talking about surrogate modeling for UQ in storm surge remote sensing. And if you'd like to snoop on the full calendar of events, I think every speaker we invited agreed, and so the calendar is full through November, and really excited about continuing the discussions with the working group in conjunction with this talk series. So come join us. And meanwhile, if you have any questions, I guess we have time now, and here's our email addresses, but thanks for your time.
Thank you, Mike and Pierre. Any questions for them?
Hi, this is John Nielsen-Gammon. You mentioned that cats and dogs is an application that's been investigated a lot in other fields, but not so much climate science. Asking the question in a different way, are there other fields besides climate science that share some of the same sorts of questions that we might want to address in big data science that we could partner with?
Yeah, I mean, or do you want to answer, Mike? Or?
Sure, yeah, you can start. I'll go after you.
Yeah, I think there are multiple fields. I mean, if we look, I mean, just my other interest in terms of turbulence, I mean, there are a couple of people doing in mechanical engineering or people in engineering trying to really bridge the gap between data and physics, you know, so there's a lot of work now trying to bridge physical models and machine learning. So with the various flavors, you know, like physics inspired, let's say, or guided neural networks. So that's happening in many, many fields. That's also happening a lot in biology, where, I mean, they have a lot of data, same way we have. And they've shown that basically hypothesis-driven doesn't always work, you know, but just because of the diversity of the data they have, you know. So I think that's happening in many, many fields. I don't think we are late in the game. You know, so oftentimes you see people feeling that they are kind of late in the game. I don't think we are. I think we are quite advanced, you know, compared to some other fields. Of course, not computer science, but because they are developing the algorithms. But compared to many other fields, I think we've been very early adopters of those methods. And some of the reasons are really also the history that we have, say, based on data assimilation. I mean, a lot of that was kind of early on machine learning, if you will. So kind of similar flavor where you have a loss function and you're trying to optimize those things. So I think a lot of the thinking was there already. At least that's my take on.
Yeah, and I think there are definite analogs to other fields. They may not be represented in our working group membership, but I think we're all having conversations in our own worlds. You know, for me, the astrophysicists and the people investigating the standard model have really interesting high-dimensional problems in formal hypothesis testing that they're trying to task neural networks with. You know, these high-dimensional nonlinear regressors are helpful in many different settings. And I'm really interested in computer scientists, you know, who do things like video compression. You know, parameterization is sort of a compression task and a high-dimensional compression task. And there's lots of links, almost an overwhelming number actually. Yeah, it's hard to focus sometimes. But we'd love to collect more links. That's part of the purpose of the group. So if you're aware, if you're noticing anything where you're seeing another field advancing in ways that you think should cross-pollinate Clivar research, please let us know. That's exactly the sort of stuff we'd like to collect.
This is Kim Cobb. I'm just wondering if there are any nascent or ongoing efforts at this area at the international scale that you're aware of that could provide interesting fodder as well.
Maybe at least in Europe, I'm pretty aware. So there's this ALICE network, which is actually very much the use of machine learning across the board, and so you have a lot of Earth system scientists actually through that umbrella, and so that's really happening across Europe, and they've been really very active on that front, I would say. So that could be one place that would be relatively easy to connect to, I would say. Yeah, they've been actually very active during COVID. Oh, sorry.
Yeah, there's definitely lots of things happening internationally. Claire's probably aware of more than I, but I had a great time at the Oxford AI workshop last fall, and you know, ECMWF has a whole different way of viewing this machinery for weather prediction, testing neural networks to create fictitious ensemble members and things like this. And it seems like there's really well-funded, large-scale efforts going on in the UK as well. Yeah.
I was wondering, in terms of the focus of the working group so far, it's been very heavy, I would say, on the neural network side of things. But I think on kind of in the broader scope of data science, there's a lot of good questions with regards to data management, data processing, high throughput data processing. So I wonder if there's anybody on the schedule, like maybe Charlie Zender or something like that, who has developed these high throughput data processing tools, or maybe somebody from like the Earth System Grid Federation, who, of course, would be responsible for managing large amounts of data as well.
So I'm not aware of anyone like that on the calendar. We were definitely challenged by one of our working group members, Ryan Abernathy, to think about the process and how limited we are in terms of the actual mechanics of processing this data in terms of what problems believe in approach. So it sounds like we already have some shared interest across the working group's core membership on that topic. And Paul, it would be great if you want to suggest some speakers to Tom on that topic. Charlie's a great one.
And also,
Yeah, we'd like to check that we're, we had a plan, which was to get to know each other first across the working group and then identify little subclusters of enough critical mass interest within the working group to actually do something where we can make an impact. But unfortunately, that plan got abruptly cut off with COVID. So we're still in the process of identifying the sub-nexuses that we're going to try to surge within the working group. And Paul, I'm taking notes about this one.
and I shared a link in the chat to the Data Science Working Group webinar series. You'll find a calendar on there that will have a list of our upcoming speakers. And I believe we're fully booked until December 7th, with one also booked in 2021. And we are taking suggestions for more speakers to round out our 2021 schedule. So if you do have any recommendations, we'll be happy to take them.
Hi, Mike and Pierre. This is Antonietta Capotondi. Thanks for your presentation. So, as you have described, there are several different possible applications of these tools and these algorithms. So I have been listening to some of Libby's talks. It's kind of more on the climate side. And I think she in particular stresses the importance of trying to actually put the hands into the black box and try to understand the important connections or the important information that the algorithm use to get the output. So some of the applications, like you mentioned, like teleconnections or maybe even like precursors of some phenomena, are also topics that are studied with other methodologies. For example, like linear inverse modeling is one of them. It's also like uses data. There are some assumptions, including the linearity, of course. But I think would be very interesting for better understanding of the machine learning algorithms, and also just in terms of sharing information. To try to intercompare these different approaches. Is there any, maybe like studying a specific problem with in different ways, with different methodologies? Do you have in mind anything like that going forward?
So is the question, do we have in mind like a community challenge,
yeah.
a teleconnection? Yeah, not at present, not one that's well articulated. We had this one aspirational goal of the program is to try to identify a community challenge project that would be worth everyone's time. And certainly the question you raised about how much of these tools are really have breakthrough potential and how many are statistically, or repackaging of tools that we already have good statistical techniques for dealing with is near the top of our mind. Yeah, I guess my first instinct here is I'm not yet sure that that's where this working group wants to make its mark. It's an interesting idea though, and one that I think that has been discussed already a few times on some of the exploratory calls. So I wouldn't be surprised if something did land there. And certainly we have Libby on the working group challenging us in that direction as well. Yeah, to me, you want to tread carefully about whether to set up one of these community competitions and how to do it, and be sure that it's going to be really addressing an issue that we need to have some coordinated effort on to understand things. And I think we're still assessing where those areas are. That's my first reaction. Pierre, what are your?
Yeah, I think there are also a couple of people that are trying to define some benchmark data sets so that to actually lead to those competitions and to exactly lead to that intercomparison of various algorithms. So that's happening right now. I would say some of them are really in the, should be up pretty shortly, I would say. So that would be nice to see that. And I think that's also a way to actually involve the, or at least that's the hope, I guess, that to involve the computer science community more into that, because I think that's been the main roadblock for them, because the heterogeneity of the data we are dealing with, they have to actually transform various data sources or data streams into what they need, And if they didn't have that pre-processing step, then I think we could have a lot more discussions, a lot more involvement of that community, and that would benefit, So I think a lot of people are trying to work on that.
It's very tempting to think of something like that, but we're also getting challenged on other issues that aren't getting as much attention, like stability and energy conservation and things like this, and quantification. And I think
also, I think another consideration is that you started off as a motivation by saying that we have a lot of data, and it's true in some cases. But do we know if we have the right data, or the right data where we most need them? Are actually the data really sufficient to solve some of the problems we would like to solve? And then in terms of future projections, are what we learn now, is what we learn now applicable to a future world?
Actually, if I may, in the statistical community, there are very clear ways to actually address that. So I have a student starting to look at those things, and I think we can really learn from those communities in terms of really clearly assessing, are we acquiring the right data and at the right place at the right time? And those are questions that are, very important, and I was like, you launch a satellite and you want to know, is that acquiring and we do have conversion things and ways to actually assess. I think we can go, we can do things in a more systematic way, yeah. I think that's doable. And there are tools out there to address that. So.
Thank you.
And yes, unique to our community, that I remember this topic emerging on one of the working group telecoms during our Get to Know Each Other's. In computer vision, you routinely have these samples of 1 million labeled images or whatever, and we only have order 10,000 daily mean satellite observations of the world conditions. And I remember there may be some gaps that are especially relevant to our community, where we have a limited observational record, and we need to better understand the sensitivity of data science techniques to intentional reductions of the amount of data in synthetic environments to understand what's possible with a smaller sample size. I could see that the working group continuing to discuss that more.
If I may just add one thing, it goes back also, I think, to the question of causal mechanisms. So I think a lot of what we are seeing in the machine learning community is a lot of correlations, right? At the end of the day, we build algorithms and they are just building up correlations. But it's quite clear, that what we want to have some predictive skill, and that's not typically the case. They do call prediction like something that's quite different from what we really mean by prediction, right? Typically what we mean by a prediction is something we haven't seen, something that's quite far from the initial distribution. And that's a major challenge. And I think a lot of the tools we have right now maybe might not be up to the task, So how do we adjust those tools? How do we massage those tools so that we can actually do that? And I think that's a major roadblock for some of the things we want to do. Climate change is number one, extremes are another one. And it's quite clear those tools don't work, so how do we address that?
Hi, this is Mike. I have a more programmatic question. And in terms of your planned activities for the next 2 years or plus, do you envision a community workshop where, as you're maturing through the evolution of your working group, where you might invite a larger community discussion about the methods and what's worked and what the challenges are going forward?
Yeah, so the short answer to that is we have not decided as a group to hold a community workshop yet. We did propose that in our prospectus, but we're still, hoping to resume now that teaching is almost over and amidst the pandemic. The discussions we intended to have after our initial get to know each other to decide whether we still agree that that's where we want to make our mark. So I can see personally, we all come at this from different perspectives. I could see a decision between really trying to focus within this very interesting core working group on trying to synthesize ourselves from what's being collected in these webinars and papers together that wouldn't otherwise happen. And you know, trying to articulate some best practices that are emerging across the group, you know, in ways that might be helpful to the community. So we may decide to spend our meeting time that way, or like you say, we may decide to hold something broader in attendance. And I think there's the discussions that are needed to settle on that were unfortunately cut off. But should happen soon.
Hi, I had a quick, hi Mike here. I had a quick comment and a question. So the comment is, probably both of you know that there is this Ocean UQ or Ocean Uncertainty Quantification Working Group, and like Pierre mentioned, uncertainty quantification is quite central to a lot of things that we do, right, in terms of either climate prediction or weather prediction or a lot of the data analysis that we do. So I think we have a couple of members who are overlapping between your working group and the Ocean UQ working group. It would be great to keep the dialogue ongoing between the two working groups, and as you see better algorithms for UQ, that would be beneficial for the Ocean UQ working group, and as we see things that are relevant for data science related things, we would be happy to engage. So that was one quick comment. And the question is regarding some of the big players in the machine learning are like the private companies, right? The private industry, which is Google, Facebook, and all that. And also a lot of the data that is being collected, at least until now, has been public, but going towards the future, a lot of data that's being collected for earth sciences could become a private or private-public partnership. So have you, in your working group, discussed about this aspect of both the data being behind paid walls or not being accessible publicly, and also in terms of the algorithm? Currently, most of the machine learning algorithms are publicly available, even though they're developed by the private industry. Going forward in the future, what would that scenario look like between data being privatized and the private-public partnership in earth sciences growing more?
I mean, I think it's going to be difficult. I mean, we don't have a crystal ball, but predicting what's going to happen, you know. But for the public-private partnership, I think you have a good point, and that's kind of starting with the Pangeo, for instance, initiative that Ryan Abernathy. And I think that's really what we are trying to see. I mean, I think we are facing a little bit of a roadblock where we don't have really a shared infrastructure that will allow the type of, I mean, the analysis of the type of data or the storage of the type of data we have, you know, and that's where those players actually come in, you know. And then it might become more and more prominent and more typical, you know. And I think it touches on many aspects, you know, like data privacy as well. So that's a lot of the discussion that's actually happening in Europe, in Germany and France, for instance, where they don't want to go that route because of data privacy. Those are tough questions. But it's true that I think that's also the trouble we are facing really as like individual PIs, you know, which is kind of the model we have right now. And whereas we need to actually share more of that data on somewhere. So how can we go around that? Good question. Those are really important.
And just as a context for the US CLIVR, like at least the PAUSE panel, which is one of the 3 panels in US CLIVR, has been engaged in the conversation of like, as private companies are launching more CubeSats and data becoming commercialized, how would this be accessible to like the wider academia? NOAA and NASA have like portion, part of their funding to purchase that private data, but likely that will not be publicly available to anyone who wants to use. So it's something that we are trying to figure out, at least both on the US CLIVOR and specifically in the PAUSE panel, on how US CLIVOR can engage with both the program side of things, on like how, if public funding is used, how do we make the data also public? But also, yeah, I think it's very relevant to some of the things your working group will discuss.
That's a great question. I mean, I was just actually in a call before that on COVID-19, you know, and talking about emissions and things. And the interesting thing is also like a lot of the data is actually private as well. I mean, you need to look at private or small companies and startups to actually get the data you want, you know, especially for the emissions. And I think, I mean, maybe one thing that could happen is it might depend on the level of granularity or the privacy that you want to attach to that, you know. So that might be a way where they would be more willing to actually share some of the data depending on the level of granularity. So for instance, for satellite data, you might not get the highest resolution, but you could get something intermediate. I mean, that might be a way to get around those things. But it's true that we need to think about those because we are seeing a lot more of that, yeah, happening.
That's very, very interesting and thought-provoking comment, Manish. Yeah, I guess I will say we thought about when we were trying to design the original core membership group about trying to invite more sort of industry, Google, Facebook type people into it, and ultimately decided the issues are uncertain enough and being discussed enough that we wanted to have industry partners that would be totally on board with the sorts of UQ needs and energy conservation constraint needs. So we have Jupiter Intelligence represented and Ryan Abernathy, the Pangeo represented, but I wasn't aware of these broader conversations. It would be great to think of ways that we could coordinate with the UQ group and get involved in them.
Yeah, I think great.
Thanks.
Thanks.
We're still not able to handle the data we do have access to, but these will likely become issues. Yeah.
Great, thanks.
Hi, this is Samson. I was wondering about the possibility. We have been talking about the possibility of having a summer school on this machine learning and specifically applications to climate. And we discussed the possibility of having both senior researchers and younger people get together, because it seems to me like there is some unease among the scientific community too as to how effectively we can use machine learning for the reasons that we just have been discussing. So it seems it would be a good opportunity here in this work, along with this working group, to see if there is an opportunity for a summer school where people would come with their little projects that could be done, sort of hackathon kind of thing. That would be the short time one, but in the long term, I think this CLIVOR and this working group could also take a lead in terms of developing a sort of curriculum for down the road for college students, for graduate students, to familiarize them with machine learning applications to climate science, because this will be the leaders of the next science. And if they are just as skeptical of machine learning and AI as older generation is, it will be a loss. So I think having summer schools involving a range of generations of researchers could advance that agenda.
Yeah, actually, I'm a big fan of hackathons as well. I mean, we have a proposal that we submitted with Mike where we did have a component on using hackathons, and I think that'd be cool because then you can directly involve this AI community very, very seamlessly, you know. But what you need before that is you need to have a pipeline. So that goes back to Antonietta's question. I mean, you need to have cleanly defined data sets where there's a very clear metrics. You know, what is what is that you're getting, and how do we define that as being better? and that we don't really have that right now. I mean, it's still,
yeah,
we're doing things like individual tests, but that's not really a pipeline. I mean, we need to have the equivalent of what the types of data set like MNIST, the type of image data set that the computer science community has. That's what we need.
Yeah. Something like SIMIP6 models or some kind of large ensemble models, you don't think they could be useful in that regard?
Yeah, I mean, for that, the feeling I have is that SIMIP6 is too heterogeneous, to really make it very usable for computer scientists. I mean, it will have to be a subset of that, or a subset of fields, or things that they will need to. So, for instance, can you predict temperature like a week from now, based on the observed temperature field, or things like that, but things that are very well defined. I think just SIMIP6 is too heterogeneous. There are too many fields, and they get confused. I've talked to computer science folks, and they just get confused when they look at those. And plus, the format is actually not ideal. NetCDF is not what they want.
I think that maybe large ensembles, and there is also a working group on that, maybe each large ensemble could still provide a lot of data, but in a more homogeneous fashion. At least it's from the same model, so there is that the diversity among models is not such a big issue. But I think for a workshop, for a summer school also, again, going back to the diversity of applications that you can do with machine learning would be important also to identify specific problems that could be tackled within the time frame of a summer school effectively using these methods. So maybe it will require a preparatory phase where you identify the data that could be suitable and the problems that could be relatively easily addressed.
So this is Mike. While we're talking about training, so there is the upcoming June 22nd through 26th virtual summer school organized by Enkar Seisel, and we can provide a link out to people if they're not aware of that one. And while that one, the idea that's been put forward by our panels during our Scientific Steering Committee meeting this March is perhaps working with that summer school to develop an online module, working with the COMET program and Unidata at UCAR, so that information, kind of some of the lessons learned there through the summer school can be shared with the broader community. So that's something that Zhuo Wang, the co-chair, she's on our SSC and co-chair of our Predictability Prediction Applications Interface panel. She's already engaged with UCAR's community programs and those other programs within UCAR to dialogue about what could be done in developing materials that could be accessible online. So that could cut across the summer. It would provide it across the different career stages, right, as well. So from students out to senior researchers could all have access to kind of a one-stop online module.
So we are 16 minutes over the time. Any last questions before we close this meeting? All right. So with the silence, then I will take that as a no. So thank you, Mike and Pierre, for presenting today. I'll send a recording out probably later this week with all of our discussion. Sounds like there's a lot on the plate for the data science working group, and hopefully also with the Ocean UQ collaboration, maybe. So stay tuned, and thank you again, Mike and Pierre, for presenting.